This is a video from eSkills Zone. For more videos, notes, and certificates, please visit www.eskillszone.com.
Hello and welcome. Hi viewers. Today in this video we will discuss a program in GW Basic Programming Language, graphics, and this program will actually demonstrate several kinds of partial circles by using the color circle statement. So let's switch to the IDE of GW Basic Programming Language, viewers. Here we are, viewers. Now in line 10 we will type RAM and then asterisk like we have been doing in our previous computer programs. Line 20 we will type RAM and then asterisk and then type circles asterisk. Line 30 once again RAM and then asterisk, and then we will type demonstrates several kinds of partial circles, and then line 40 and then RAM statement and then asterisk like this. So this is a better way to write the top heading of any computer program like we have been doing. So you should keep practicing of typing all these RAM commands to type asterisk and then name of the program like this. It will help you out in future, so that whenever you forget about the topic or the purpose of any program, computer program, you can just identify it from the heading that what is the purpose of this computer program and what this is all about. So in line 50 we will type screen 1. Line 60 we will type color 1, line 70 we will type RPD, name of the variable of type single precision, and I'm gonna type 0.1745332. So this actually value is assigned from the right hand side. This value will be assigned to this RPD single precision because we have used several numbers, and because integer cannot support it, that's why we have used single precision having exclamation symbol and starting with the fractional decimal point. Line 80 we will type circle and then type the coordinates as 50, 30, and then starting and ending point is 20, 30, and then 90 into RPD single precision variable, 180 into RPD. So first we have multiplied the RPD with 90 and then 180. This is the attributes, start and end values, x and y coordinates, 50, 30, starting value 90 into RPD, 180 into RPD, and then color and then radius. This is radius and this is color. Line 90 we will type circle statement once again having coordinates 100, 30, 20,3 comma 180 into RPD, and then 90 into RPD. I'm gonna type this line once again, 3 comma 90 into RPD, and then 180 into RPD, like this. Line 100, circle 150 comma 30 comma 20 comma 3. So you can see that the radius and the color remain same throughout the line 80, 90, 20. This value 20 is used for circle and 3 is used as a color. So you will see 3 different circles having the same color and same radius, but since we are multiplying its starting and ending values with the RPD, and RPD is assigned a value 0.174532, therefore we will see different circles at different positions. So line 100, now I'm continuing this line, 20,3 0 into RPD, and then 35 into RPD, line 110, circle 200 comma 30 comma 20 comma 3, and then starting and ending values are 360 into RPD, starting value, and the ending value is 35 into RPD. Line 120, circle 250 comma 30 comma 20 comma 3 comma 20 into RPD, comma 200 into RPD, line 130, circle 100 comma 100 comma 50. You can see over here this circle is going to have a different radius and different, but having the same color, comma starting value as 45 into RPD, and then ending value as 135 into RPD. A quite lengthy and quite technical program we're gonna execute today. And now I'm gonna press F4 key and type the name of this program as several circle. I'm gonna type several cir.bas, or I can just type several.bas, pressing the enter key, and I'm gonna press the F2 key, so you can see different partial circles on the screen at different position. So let's switch to the text area, where I'm gonna interpret the whole execution of this program line by line for your better understanding and concept. So let's switch to the text area, viewers. So viewers, you have executed the program, this very program which demonstrates several partial circles on the screen. That was the program you executed using different circle statement, having different x and y coordinates and having same radius from line 80 to 120. You can see we have used the same radius, same colors, but the value of the starting and ending points are quite different from one another. So this is the output of the same program we have just executed in the IDE of GW basic programming language, and you can see partial circles of different kinds on the screen. So I'm gonna interpret this program. So let's start. First, look at line 70. The RPD single precision variable holds the number of radians per degree that is how many radians fit in 1 degree. Next, compare each circle statement with the syntax explanation. Be sure you understand each option. Know which numbers define the radius, the color, and the start and end position. Now look at line 80. The first circle command, this circle begins at the 90-degree position of the circle. Since the circle statement needs the position in radians rather than degrees, we let basic multiply 90 by the RPD variable. This keeps things simple for us. The circle begins at 90 degrees and continues to 180 degrees. In the next circle statement on line 90, the start and end positions are switched. This circle begins at 180 degrees and moves counterclockwise to the 90-degree position. All circles are drawn counterclockwise wise, the next two circles are the same. Check lines 100 and 110. In the first, the right edge of the circle is position 0. On line 110, this same position so I'm talking about the line 110. On line 110, this same position is 360 degrees. This is just like a compass. Compass north is both 0 and 360 degrees. The circle command line has one final trick for us. We can turn circles into pies by making the start or end numbers negative. When a negative number is used, BASIC draws a line from the center of the circle to the edge. To get pies, we need to place a minus sign in front of each number listing degrees. We have one exception. BASIC will not allow 0 to negative. Thus, line 100 cannot have a line drawn to the right. To get a line drawn to the beginning point of a circle, use a negative 360. So viewers, this is the whole interpretation of the above program we have executed today, which actually demonstrates several kinds of partial circles, as you can see as an output on the screen. And here is the complete interpretation of the above program. Hope you will like it, and it really helps you out in understanding how we can draw partial circles on the screen by using circle statement. That's all. Thanks for watching.